A very good morning to all of you. Students, in chapter hydrocarbon, we have completed general introduction of alkene. Then we have completed method of preparation of alkene. Then we have seen about physical properties of alkane, and at last we have completed chemical reactions or chemical properties of alkenes. Now, in today's lecture, we will talk about method of preparation of alkenes. How alkenes can be prepared. Which organic compounds can be used for the preparation of alkene. But before that, let me remind you some simple points related with alkenes. Number one, you know it very well, that alkenes are the compounds which follows general molecular formula CnH2n. There is a presence of double bond between the carbon-carbon atom. Alkanes are called paraffins due to their little reactivity. Similarly, alkanes are called olefins, O-L-E-F-I-N-S, olefins, oil forming, because all the oils, cooking oils, contains alkenes. Between the carbon-carbon atom, where double bond is there, the bond length is 1.34 angstrom. Or the bond length of olefinic carbon atom is 1.34 angstrom, 1.34 into 10 to the power minus 10 meter. Carbon, which is forming double bond, is always have trigonal planar geometry. Bond angle of 120 degrees there. Now, let us move to method of preparation of alkene. So, first method is using alcohols. If we carry out dehydration of alcohol, I have taught you in elimination reaction. If we carry out dehydration of alcohol, then alcohols will be converted to alkenes. Dehydration means removal of water. So if water molecule is removed from alcohols, then alcohols will be converted to alkene. And for removing water molecule, we require dehydrating reagent. Dehydrating agent, the substance which can remove water from alcohol. And here we can use concentrated H2SO4. So if alcohols are heated in presence of concentrated H2SO4 at a temperature of 443 Kelvin, 443 Kelvin, then alcohols will be converted to alcohol. So here is your reaction: hydrogen, carbon, hydrogen, hydrogen, carbon, hydrogen, hydrogen, and your OH group. CH3CH2OH, this compound is called ethanol. Now, ethanol, when heated in presence of concentrated H2SO4 at a temperature of 443 Kelvin, then removal of water molecule takes place. How water is removed is important. OH unit from this carbon, which is called your alpha carbon, and hydrogen from the neighboring carbon, which is called beta carbon, is removed. So H from here and OH from here is removed in the form of H2. So H with OH gives you H2O here. Now, when one H is removed from carbon, it creates a bond efficiency of 1 over this carbon. When OH unit is removed from this carbon, it creates a bond efficiency of 1 over this carbon. So, both the carbon atoms are one bond efficient. So, for satisfying their bond efficiency, there will be formation of new bond between the carbon-carbon atom. So, here, ethanol will be converted to ethene when heated in presence of concentrated H2SO4 at a temperature of 443 Kelvin. Remember, this temperature is important, 443 Kelvin. If the same alcohol is used with concentrated H2SO4 at a temperature of 413 Kelvin, then alcohols by dehydration will be converted to ether. That we will talk about in class 12. Now, the next one is your by dehydrohalogenation of alloalkane. Dehydrohalogenation. D stands for removal. Hydrohalogenation. Hydro for hydrogen. Halogenation means for X. That is your halogen atom. So here HX molecule will be removed. Hydrogen halide will be removed. Again, a type of elimination reaction in which HX molecule like HCl, HBr or HI is removed. Now, to carry out dehydrohalogenation reaction, we will require dehydrohalogenating reagent. And for this, we will be using alcoholic KOH. So if haloalkanes or alkyl halides are heated in presence of alcoholic KOH, then haloalkanes or alkyl halides undergoes dehydrohalogenation, as a result of which we obtain alkenes as the product. So here let us use bromoethane. This is your bromoethane. This carbon where group is there is called alpha carbon, and the next carbon is called beta carbon. So bromine from alpha is the rule. The carbon atom to which functional group is attached is called alpha carbon. Then the next carbon is called beta carbon. So H is removed from beta carbon in presence of alcoholic KOH on heating. So what will happen? H with Br will be removed in the form of HBr. The H will combine with OH, forms H2O, and Br combines with K, forms KBr. Now, removal of H from beta carbon creates a bond efficiency of 1 over beta carbon. Removal of Br from alpha carbon creates a bond efficiency of 1 over alpha carbon. So alpha and beta carbon both are one bond efficient. So for satisfying their bond efficiency, there will be formation of new bond between the carbon-carbon atom, as a result of which we will obtain HCH, double bond C, H and H. H with OH forms H2O, and Br with K forms KBr. So compound used here is bromoethane, which is converted to ethene. So alkyl halides on dehydrohalogenation forms alkene as the product. Remember, here hydrogen is always removed from beta carbon. That's why this reaction is also called beta elimination reaction. Hydrogen will always be removed from beta carbon. So this elimination reaction is also called beta elimination reaction. Now the next one is your by dehalogenation of vicinal dihalides. Now what are vicinal dihalides? When the halogen atoms are present on neighboring carbon atom. When the halogen atoms are present on neighboring carbon atom, then the dihalides are called vicinal dihalides. Clear? So here I can use hydrogen, carbon, hydrogen, carbon, hydrogen, hydrogen. Here your Br, here your Br. They are two bromine atoms, halogen atoms present on neighboring carbon atom. So this compound is 1,2 dibromoethane, a type of vicinal dihalide. Clear? Dehalogenation. D means removal. Halogenation means halogen molecule. X2. It can be Cl2, it can be Br2, it can be I2. Now what we require? We require the presence of zinc powder and methyl alcohol. When heated, what happens? Br from here is removed as Br2. The removed Br2 reacts with zinc powder and forms the side product as ZnBr2. Now, removal of Br from here creates a bond deficiency of 1 over carbon. Removal of Br from here creates a bond deficiency of 1 over this carbon. So both carbon atoms are 1 bond deficient, so there will be formation of new bond between the carbon-carbon atom, as a result of which we obtain ethene as the product. Clear? So there are three methods by which alkenes can be prepared. First, dehydration of alcohol, removal of water molecule in presence of constant 3h2SO4 at a temperature of 443 Kelvin. Removal of HX molecule in presence of alcoholic OH, and removal of halogen molecule in presence of zinc powder and methyl alcohol. So by three methods we can prepare alkene. In next lecture we will talk about chemical reactions of alkene, the most important part of this chapter. Thank you and have a good day.